All right, class, so let's go over another example of hypothesis testing. So a study included 71 children who were wearing seatbelts when injured in motor vehicle crashes. So this is going to be our sample size. The average amount of time spent in an intensive care unit by these children was 0.83 days. This is our sample mean. With a standard deviation, our sample standard deviation of 0.16 days. Using a 0.01 significance level, that's our alpha, we want to test the claim that the sample of children wearing seatbelts comes from a population with a mean of less than, this is really important, 1.39 days. 1.39 days is the population mean for children who are not wearing seatbelts. So up here we had children who were wearing seatbelts. This mean of 1.39 days is for children who are not wearing seatbelts. Our question is, do the seatbelts seem to help in terms of fewer days spent in intensive care? So let's go ahead and define our H naught. So our H naught is that this sample comes from the population whose mean is 1.39 days. And we're looking for an alternative hypothesis that has fewer days. So we're saying our sample mean has fewer days spent in intensive care. So that's going to be a less than. So now we have our null hypothesis and our alternate hypothesis. We need to calculate our test statistic. So we already know our null hypothesis and our alternate hypothesis. We identified that our sample size was 71. Our sample mean was 0.38. My sample standard deviation was 0.16, and my alpha was 0.01. But something's missing here. I don't know my sigma, right? This is our population standard deviation. And because of this, I cannot do a z-test. I'm going to have to do a t-test. So we're going to compute our test statistic using a t-test. So I know my t-value is our sample mean minus our population mean over our sample standard deviation divided by the square root of n. And that gives me negative 38.88. Whoa! Remember, this is measuring standard deviations. And our 6895 99.7 rule tells us that we've got 99.7% of the data within 3 standard deviations. But here I've got negative 38 standard deviations. That's unbelievably far. Well, wait, right? We have to go to a critical t-value. We have to use our t-table. Remember that this is not a z-score, right? So we aren't going to our z-table. We're going to our t-table, which is different. So we have degrees of freedom of 70 because our population was 71 and our degrees of freedom equals 71. And we go over to find a critical t-value of negative 2.381, okay, from our table. Since negative 38.88, that'd be like way over here, lies in our critical region, we reject the H naught and conclude that seatbelts seem to be helpful. Well, we all knew this, right? So another way of stating this is when we reject a null hypothesis, we're really saying that our sample of children who were wearing seatbelts comes from a different population than those who are not wearing seatbelts, right? The sample of children wearing seatbelts comes from a population whose mean time spent in intensive care is less than 1.39 days. So the problems we've been working on come from section 8-4, which is testing a claim about a mean. These tests are using a traditional method. Now I want to show you the 2 other methods that will use hypothesis testing.